Section R.7, rational expressions. What a rational expression is: if we form the quotient of two polynomials, the result is a rational expression. So basically, a rational expression is a fraction involving polynomials. The numerator is the top of the fraction, then the denominator is the bottom of the fraction. So here we have these examples. All these examples are examples of rational expressions. They all have polynomials on the top and in the bottom. A rational expression is reduced to lowest terms by factoring the numerator and the denominator completely and then canceling any common factors using the cancellation property. So when we're looking at a rational expression, let's say we started off with something like this. To reduce it into the lowest terms, we'd be factoring out common factors. So we factor the top completely, factor the bottom completely. We look for what factors or kind of what sets of parentheses they have in common, and then we have the leftover stuff. In this case, we keep track of sometimes, not always, but sometimes we keep track of the domain. X cannot be -2 or -1, because if it was -2, we'd have a 0 on the bottom. If it was -1, we'd have a 0 in the bottom. So trying it with an example, let's suppose we had to reduce this rational expression in lowest terms. We would want the top and the bottom completely factored. Right now the top is completely factored. The bottom, that's the difference of perfect squares. So we can factor that into x minus 4, x plus 4. I see a factor of x plus 4 on the top, on the bottom. Those are what's going to cancel. And so we're left with, in the bottom, an x minus 4. In the top, we are left with a factor of 1. It's kind of like if you were going to reduce something like, let's say you reduced 5/10 as an example. Well, this is 5 over 2 times 5. The 5's reduce. We're still left with a 1 on top. So the same thing would be true there. Another example, reduce the rational expression to lowest terms. So we want the top and the bottom factored. When I look at if I start with the bottom of this one, I see in both of these terms, the 15x squared minus the 5x, I see they have something in common. They have a factor of 5x in common. I factor that out. What would need to go here and here to get back to the 15x squared minus 5x needs to be a 3x and a minus 1. When I would multiply that out, I would get back to this bottom. The top, I'm looking for factors. There's different ways to factor the top, but what I see 5x times 4x. The reason I see 5x times 4x is because I know there's a 5x in the bottom, so hopefully I can cancel something out. And I know the 5 times the 4 is going to give me 20. The x times the x is going to give me x squared. So there's a 5x, a factor of 5x on top, and then in the bottom, they cancel out. We're left with 4x over 3x minus 1. Another example, reducing this one to lowest terms. We want to factor the top and the bottom completely. So I don't really see much with the bottom right now, but in the top, I see the top can be factored into, looks like an x plus 7 and an x minus 2. And then I'm looking at the bottom. The bottom, the 2 minus x, I don't necessarily see something, but what I do notice is that this right here is sort of close to this there. It's just the signs are off. So on the bottom, what I can actually do is factor out a -1, and then it would be minus 2 plus x if I factored out a -1. A minus 2, a positive x, we have a positive x, a minus 2. Those are the same factor. So we end up with x plus 7 over -1. We're dividing by a negative. It's going to make this a negative quantity of x plus 7. And there would be our answer there. When we multiply or divide rational expressions, multiplication, what this is saying is you multiply straight across the top, multiply straight across the bottom. When you divide, you multiply by the reciprocal. So multiply by the reciprocal of the bottom. the reciprocal is just the fraction flip, so d over c. And then after you multiplied by the reciprocal, then we can reduce. So if we try it with this one, here we have a great big fraction. We have the top 12x over 5x plus 20. That little fraction is in the top of the big fraction, and then this little fraction is in the bottom of the big fraction. So when we do this, when we divide by a fraction like 4x squared over x squared plus minus 16, we're going to multiply by the reciprocal, which is x squared minus 16 over 4x squared. So we multiply by the reciprocal. So in the top we're going to have 12x. We multiply straight across the top times x squared minus 16 over 4x squared times 5x plus 20, multiplying the tops and the bottom. Then factor it, see if anything's going to factor out. So on the top, the x squared minus 16 is x plus 4 times x minus 4. In the bottom, 5x plus 20. In the bottom, that 5x plus 20, I see that's going to factor into 5 times x plus 4. What about the 12x and the 4x squared? Well, 12, I see that as a multiple of 4 times 3. So I'm going to do this as 4x times 3. That would give me the 12x. And then in the bottom, 4x squared would be 4x times x. So I look for factors after I got it factored that are the same in the top and the bottom. The x minus 4 is the same top and bottom. And also the 4x is the same in top and bottom. Which means in the top I'm left with 3 times x minus 4. The directions say leave in factored form, so I can just leave it 3 times x minus 4. In the bottom, the x times 5, or 5 times x, 5x, usually put the number first, and then that factored out. So that's all there is. So in the top, 3 times x minus 4, and in the bottom, 5x would be our answer for that one. And that's what we get after we multiply by the reciprocal, multiply top times top, bottom times bottom, and then simplify. So another example maybe looks a little bit worse, but here we're going to divide by this fraction here, which means we're going to multiply by its reciprocal, which is it flipped, so x squared plus 5x plus 6 over x squared plus 5x minus 6. When I do that, we're going to take this top times this top, bottom times bottom, all in one great big fraction. When we multiply these, we could multiply them all together, but we eventually want to factor to see if we can factor things out. So instead of multiplying them together and then trying to break them apart, I'm just going to start factoring them right away. The x squared plus 7x plus 6 would factor into an x plus 1 and an x plus 6. The x squared plus 5x plus 6 factors into x plus 2 times x plus 3. In the bottom, the x squared plus x minus 6 factors into x plus 3 and x minus 2. And the x squared plus 5x minus 6 factors into x plus 6 and x minus 1. Then look for factors that are the same. The x plus 1, no, there's no x plus 1. X plus 6, yes there is. X plus 2, no there's not. X plus 3, yes. So all said and done, the factors that are left on top are x plus 1 times x plus 2, and the factors left in the bottom are x minus 2 and x minus 1. And that would be this simplified. What about when we have to add and subtract rational expressions? Well, if what this is saying here, if a over b and c over b are two rational expressions, then when we add them together, all we have to do is add the tops. The bottom stays the same. And this is true not just of rational expressions, but if you think about it with like a fraction, let's say we had 3/7 plus 2/7. You just add the tops together, the 3 plus the 2, and the bottom stays the same. With subtracting, as long as the bottoms are the same, the tops just get subtracted, just like you would do with normal fractions. Let's do this one here. We've got a 5x minus 4 over a 3x plus 4 minus x plus 1 over 3x plus 4. Those bottoms are the same, so that we can just subtract the tops. The bottom is going to stay the same, just like it would be with normal fractions, and we're going to take the 5x minus 4, subtract the other top x plus 1. So when we simplify the top, the bottom is just going to stay the same, but simplifying the top, 5x minus x is going to be 4x's. What I usually see missed is that this minus applies to everything, so it's going to be a minus 1. Minus 4x minus 1 is minus 5. I look at the top and the bottom to see if there's anything that can be factored out to try to simplify this. And when I'm looking, I don't see anything that can be factored out. So there's my answer there. What do we need to do to add or subtract rational expressions that don't have common denominators? Well, if the denominators are different, like here, then what we have to do is get the same denominator. So kind of like if you had 2/5 plus 3/7, those two fractions don't have the same bottom. You'd have to get common denominators. That's what this is saying right here. You have to get common denominators. So what you can do is take this fraction times this denominator, and when you do that, you have to do it to both top and bottom. Kind of like we won't change, if we change 2/5, we would have to change both the top and the bottom. Well, here you change both the top and the bottom by the same factor. And the c over d, you change both top and bottom by the same factor. Once they do have the same bottom, then you can add just the tops. Same is true for subtraction. Get the same denominators. Once the denominators are the same, just subtract the tops. Well, what does that actually look like in practice? Perform this operation, so perform this subtraction. Leave your result in factored form. 2 over x plus 5 minus 5 over x minus 5. If you look at those, do they have the same bottom? No, they do not. So we would have to get the same bottoms. The 2 over the quantity x plus 5, what is this fraction missing in the bottom that this one has? It's missing the factor of x minus 5. If we do that to the bottom, we have to do it to the top, just like we would do with normal fractions, and then minus the 5 over x minus 5 is missing. Compared to this one, it's missing the x plus 5. So we're going to put the x plus 5 in the bottom. If we do that to the bottom, we have to do it to the top, like that. So in the top of this first fraction, we're going to have 2x minus 10. In the bottom, x plus 5, x minus 5, minus the second fraction, we'd have 5x plus 25 over x minus 5, x plus 5. We're subtracting these two. Do they have the same bottom? They have the same factors in the bottom, so yes, they have the same bottom, even though the factors are out of order. The order we multiply things in doesn't make a difference. So we can subtract the tops. We can take the 2x minus 10, subtract 5x's plus 25. The bottom is going to stay the same. The x plus 5, x minus 5, those two factors have to be in the bottom. And when we do that, we're going to get negative 3x's minus 35 over, don't forget when you subtract, you have to subtract everything, and over the x plus 5, x minus 5. And there would be our answer. We check the top to make sure we can't factor anything out. To simplify it at all, I don't see anything, so that would be that fraction completed. Good luck. Again, if you ever need some more explanation or looking for a little bit longer videos, you can always go to the author's videos, which are in the chapter contents.